Okay, so the last example for differential equations is an example which is going to include some power in it as well. Okay, so we need to be able to make our link from power from unit 3. So when it comes to this one, the first part is going to be very, very similar to what you've been doing. Okay, but the second part is quite tricky. Okay, and it's going to include a lot of your pure work, so we'll have to slow it down quite significantly for that one. Okay, the first thing, start with our diagram and go from there. So I've got an electric vehicle has a mass of 1,200. Okay, didn't need to go up there. So 1,200. So I've got working at a constant rate of this. So straight away, there's my power. Okay, now let's remember my power equation. Okay, power is F V. Okay, so if I want the force is going to be power divided by velocity. Now in this case, I don't know its velocity, so it's got a driving force that's 21600. Let's remember that's in kilowatts. I want it in just watts, all over V. Okay, that's my first part. Let's move along. It's got a resistance R, which is proportional to the speed. So remember we talked about in the last video, if it's proportional, straight away, let's just put KV. And then we can go from there on the rest of it. So it's going to be moving to the right, V, it's got an acceleration to the right, it's A. If the maximum speed of it is 108 kilometers an hour, so again, maximum speed, A must be 0, that's V, okay? And then we've got our actual question. So the first thing, let's do our normal thing. Let's use Newton's second law in the direction of motion. So that means I've got 21600 over V minus KV, that's in the opposite direction, is 1200A. Okay, all I'm going to do a little bit, okay, is I'm going to firstly use this purple thing that I've underlined, and that's the fact that the maximum speed is 108 kilometers an hour. Now, the reason why I'm going to use that is because in this equation, I want V's. Okay, I want them there. Okay, I know I'm going to eventually change this A out for some sort of derivative. Okay, and then the issue is this K. If you've got a constant proportionality, there should be something in the question for you to find it. Okay, so that's what I'm going to try and find now. So I know at the maximum speed, A is 0, so this is max speed. I know V is 108 kilometers an hour, which doesn't really help me because I need it in meters a second. Okay, to do anything. So I need to change it. So I need to change 108 into meters a second. So we're going to times by 1,000, then divide by 60, divide by 60 again. Okay, gives me 30 meters a second. Okay, let's sub those into there. That gives me 21600 over 30 minus 30k is 0. And I'm going to solve this for k. Comes out as a nice 24. Okay. Now let's put it back in. 21600 over V minus 24. V is 1200A. Okay. Now I'm going to rearrange this equation before I do anything. Okay. I don't like this fraction. So let's times everything by V. Okay, and then I'm going to try my best to get rid of some of these numbers. Now, if I look at them, I know that 24 should go into this. I'm going to quickly check to make sure it does. It does, so let's divide everything by 24. Is going to end me with 900 minus V squared is 50V and an A. Okay, so that's my far, far more improved equation that I'm going to use now for the rest of this. Okay, so now let's jump into the first part. Okay, so let's think about what the question wants from here. Find the time taken and the distance traveled. So I need two things. By vehicle to accelerate from 18 kilometers to 54 kilometers an hour. Okay, so I need to do two different things. I need to find time taken and a distance, and they've given me velocities. So that tells me the relationships I'm looking for. So for the first part, okay, I'm going to be looking for a relationship with time and my velocities here. Okay, so straight away, dv by dt. So I'm going to use a equals dv by dt for the first bit. I'm going to sub it in. So I've now got 900 minus v squared is 50v dv dt. Okay, and let's follow my normal pattern. Let's separate my variables. So dt is going to come up to here, and there's nothing to be left over. I'm going to have 50v over 900 minus v squared. I'm going to integrate this side. Okay. Now, left-hand side, nice and easy. Right-hand side actually looks a lot easier than I think it looks at the beginning. Okay. Now, we leave this 50v, don't we? Always leave what's on top. Okay. However, I need to make sure that v isn't there anymore when I finish, which it shouldn't be, because if I think about what's going to happen, I'm going to do log of 900 minus v squared, which is great. Okay, but I'm going to divide by the derivative, so I'm going to divide by minus 2v. Okay, now if you notice, my v's are going to cancel. So I end up with t plus c is minus 25 ln of 900 minus v squared. Okay, so it's all good. Okay, if it wasn't going to cancel here, I'd have to think of a different way of integrating it, which we're going to see in the second part of this question. Okay, right, now I need to find c. Now if I go back to the question, there's no like, oh, initially it was this or anything like that for me to substitute in, because I need a time and I need a velocity to sub in. Okay, but I need a time taken between these 2 points. Okay, so to help me, let's make this first time when time is 0. Okay, and then I can decide from there what to do. Okay, so we're going to make that first when time is 0. Okay, so I've now got the fact that when t is 0, velocity is going to be 18 kilometers an hour. So let's use that to find my c. So I'm going to have to just go very quickly next to it by here. Okay, let's keep all this pink stuff together. So I've got when t is 0, v is going to be 18 kilometers an hour. Again, that doesn't help me. Let's change it into meters a second. That's going to be 5 meters a second. Okay, so I know c is going to be minus 25 ln of 900 minus v squared, so minus 900 minus 25 in this case, which is going to be 875. Okay, and what I'm going to do is I'm going to sub c into here and rearrange it all at once now. Okay, you should be fairly comfortable with this kind of movement, but please just do it bit by bit. Okay, I'm going to end up with 25 ln of 875 all over 900 minus v squared. Okay, now it hasn't asked me for a general equation, but I do need time, so I do need it in the term of t equals, which it is. Okay, now let's do v equals 54. Okay, now the reason why I did the whole let t equals 0 for this first one is because I'd only end up doing the first, like this 54 one, take away the 18 kilometer one. Okay, anyway, so if I make that time as 0 in the first place, then I don't need to do any subtracting afterwards. Okay, so again, let's change it. That is going to be 15 meters a second. And let's substitute it in. So I've got t equals 25 ln 875 over 900 minus 15 squared. Okay, which comes out to be 6.49 seconds. That's the time it's going to take, okay, between those two velocities. Okay, so there's my final answer. Okay, so very, very similar to what we've been tackling in the previous ones. So for the second bit, we need to be careful of what we're going to deal with now, okay, because it's going to get quite complicated. So I'm going to try and like split this off a little bit. Okay, so for the second part, let's go for a green. Let's go for orange. Let's go for the color we haven't used. I want the distance traveled between these two. Okay, so now I want acceleration and I want v dv dx. Okay, because that's the relationship that I want. I want distance and velocity. Okay, so let's substitute it into my blue one by here that I had. Okay, the really, really important one. So I've got 900 minus v squared is 50v times v dv dx. Okay, and if you notice what we're going to have here, we're going to have something not very nice to deal with. So 900 minus v squared is 50v squared dv dx. So let's do my rearranging like we normally do. I've got dx on this side, then I've got 50v squared over 900 minus v squared dv. Now we've got the issue now with this fraction singular. I'm going to integrate both sides. Okay, when I did the pink one over here, okay, my v's cancelled by here, didn't they? Okay, but in this scenario, they're not going to cancel. I'm going to be left with a v, which causes me an issue. Okay, so to help myself, what I'm going to do is I'm going to use some polynomial division. Okay, so I'm going to do 50v squared divided by 900 minus v squared. So I'm going to first do how many times does minus v squared go into 50 v squared when it's going to go into minus 50 times. Okay, and I'm going to do minus 50 times all this. So minus 50 times 900 would be minus 45,000. And I've got minus v squared times this gives me a positive 50 v squared. And I take these two lines away. So I've got minus gives me a positive 45,000. And then these two should cancel, which they do. So that's my remainder. So in other words, that means what I can do is I'm going to rewrite these out. I'm going to have the integral of minus 50 plus 45,000 over 900 minus v squared dv, okay, which helps me a little bit. So this side is going to go to x plus c. This side, minus 50v, fine. However, this fraction, okay, I've got the same issue again, okay, with the fact that it's going to have a v left over on the bottom when I divide by a derivative. And I don't want to have any v left over, okay. However, this looks very, very similar to something in your formula booklets, okay. So you're 1 over 2a log of a plus v, a minus v, okay, when you're trying to integrate something in the form of 1 over a squared minus x squared, or v squared in this case. Okay, there's a very similar form, so let's use that to our advantage. So I've got 45,000, let's leave my coefficient alone, okay, over 2a, so if 900 is a squared, a must be 30, so 2 times 30, okay. Ln of 30 minus v all over 30, oh sorry, 30 plus v over 30 minus v, the other way around. Okay. Okay, so that's what we end up with by here. Okay, so now what I'm going to do is I'm going to slowly work my way through to find my other bits. Okay, so usual things, let me just put a line by that so we don't get confused about different things. Okay, I need to try and find c. Okay, so I'm going to use x is 0 when v is the 18 kilometers an hour. Again, I'm going to do the similar kind of like thinking behind the last one. Okay, so I'm going to use 5, sorry, in this case. So I've got c, it's minus, so I've got 250, 50 times 5, plus this is going to come out as 750, so I've got 750 ln of 30 plus v, so 35 over 30 minus, so over 25, okay, which can simplify a little bit, so 250 plus 750 ln of 7 over 5. Okay, now I've now got my final equation for x. So x is equal to, let's take everything over to the other side, so minus 50v. Then I've got plus 750, oh, if I can write things, plus 750, because remember that's what this fraction is here, ln of 30 plus v over 30 minus v. This is going to be negative when I take it over to the side, so minus 750 ln is 7 over 5 plus 250. Okay, now I don't really want an expression. I could try and put these two together, okay, in the middle, but it's fine. I don't really need to do that. I'm just going to go straight into, okay, when v is 54 kilometers an hour, which means it's 15 meters a second, x is equal to, and I'm going to simply sub 15 into that equation. Okay, and it comes out as 71.61 meters. Okay, again, I could have put these two together, but there's no actual need for me. Okay, now that orange bit is kind of an extreme answer. Okay, I'd be massively surprised if anything came up that difficult. Okay, however, you do need to be aware of applying some of that pure work that you do into these kind of questions at the same time. Okay, but the key reason for me doing that one was the fact that you had to use one of the other accelerations, so using v dv dx. Okay, so that's differential equations. Okay, as before, below is the new spec questions and the answers for each of those. Okay, so please have a go with them. There's also some old spec M3 ones. Okay, it's from Welsh website. Okay, so that's why it says half and stuff, things like that. Okay, but you can find all of these answers online. Okay, so if there's anything else to do with differential equations, please email me and let me know. But apart from that, I'll see you in the next topic.